And we live again. Welcome back again, students. This video is discussing lesson 19. Lesson 18 was about the Pythagorean theorem. That video, I made it short and sweet for you. For lesson 19, we're actually going to be putting it to use to solve for the length of the hypotenuse. Okay? And I'm going to try to make this video short and sweet for you. First, we have our fluency, which is our warm-up. We're working with, again, our square root formula here. Expect to use it a lot for this particular lesson. Our square root formula is x squared equals p. For this particular set of questions, it just wants us to solve for the variables. I know it says solve each equation. I'm just going to write on the side, you're solving for the variables. So you're solving for the x values. For number one, I did it for you. It says x squared equals 1. I need to figure out what is the value of x. I know that 1 times itself anytime is always going to be 1. But remember, once again, that when we are solving for these squared values and we need to square root a number to get the original x value, that our answers are always going to be a positive number and a negative number. So there's always two answers for positive squared values. So for number one, we have positive 1 and negative 1. For number 2 through 6, do those on your own. But do remember, you will have a positive answer and a negative answer, and they are both correct. The reason being is because a negative times a negative is a positive, and a positive times a positive is still a positive. This is our lunch. I know it looks a little crazy. This is really supposed to be an activity. Don't worry about it right now. Don't worry about it right now. This is more so just showing the different versions of the same thing, but we'll discuss it in just a second. Here, finding the length of the hypotenuse. Part 1 of 3, this is where we're starting, the Pythagorean theorem. If you remember from yesterday, we have our side A, we have side B, which are both legs. A and B are legs to our right triangle. You know it's a right triangle because we have this square here that lets us know that this measurement here is 90 degrees. And then we also have C. C is our hypotenuse. And I'm going to just label it a little bit. Hypotenuse. I do want to make sure I exaggerate a little bit that B, just note this somewhere, that B can be representative of distance. And when I say B, I'm talking about B just for a specific triangle, because this is a horizontal line, and this can be representative of distance. In this particular case, A can be representative of height, okay, just because it's long and it's vertical. This can be height. C can be represented or thought of as like not just a hypotenuse, but depending on the scenario, it can be thought of as a line of sight. Think about it that way, a line of sight. Or it can be thought of as distance at an angle, like if I was looking up to something from the bottom, or just a downwards measurement of something. Okay? Moving on. For problems 1 through 4, find the length of the hypotenuse. Underline that. Hypotenuse. Our hypotenuse is always C. That will never change. Ever, ever, ever. We already know our formula. Our formula is A squared plus B squared equals C squared. Write that formula every time you see something about hypotenuse, Pythagorean theorem, or right triangles, or whatever. Write that formula every single time. Do not forget it. Now for number 1, we have our right triangle. We have side length A. Make sure you label A equals 8. We have our bottom side length or our bottom leg length. B is 6. And then we have C. All we need to do is plug in. That is it. So A squared, A is 8. So we're just going to put 8 squared plus B is 6. B squared equals c squared, because that's what we're looking for. So did I write b? This is a 6. Then we solve. So we're just going to break down these squared values here and solve for those. I know that 8 times 8 is 64. 6 times 6 is 36 equals c squared. 64 plus 36 is 100 equals to c squared. And I can actually break this down further, but I'm going to hold it. I'm going to hold off on it for right now. Number 2, we have another right triangle, obviously, but it's been turned sideways a little bit. Remember that your hypotenuse is always right across from your right angle, and then the line that is vertical to the right angle, if it was upright, is your A. So 12 is A, we'll make our B 5. In most cases, when you just have a generic triangle and some numbers, it usually doesn't matter which one is A or B. But if you had a scenario, if you were given a scenario, you would definitely need to label A and B correctly, just in case. But that's another lesson. We'll get to that later. Right now, we're just plugging in. We already identified that our A is 12, our B is going to be 5, so we're just plugging in. Our A squared will be 12 squared. Our B squared is 5, so B squared is 5 squared, and then we have C squared. 12 squared, I know that's 144. 5 squared is 25. 144 plus 25, that'll give me 179 equals C squared. Now, take notice that it wants the length of hypotenuse C, and it just says C, not C squared, just C. So if I wanted to undo this a little bit, and I'm just working ahead a pinch, I would have to take the square root of our numerical value to get C. And I'm just doing it for number 1. So C would be 100 square rooted. The reason being because to get C alone, not a squared C value, but just C, I would have to square root the C squared as well. To get 1 C, that's all we need. Also, the square root of 110, but once again, we'll get back to that later. I will leave you to do 3 and 4 on your own. Do not be intimidated by decimals. If anything, just plug them into the calculator and that will still give you what you need. Just make sure you set up the formulas correctly. That's all you need to be concerned with. Same thing with this fraction. Don't be intimidated by that fraction. That's 5 over 4. Once you square it, that'll give you 25 over 16. You can break that down into a decimal. And then add that to 3 squared. And that'll give you C squared. So do not be intimidated. Do not get confused. The rules still are the same in everything we are doing with this A squared plus B squared equals C squared will still apply. So don't start plugging stuff in weird just because the numbers change. We do it the exact same way. Nothing special. Here, we're going to get into reasoning about the length of a hypotenuse. All reasoning means is that we're not going to have a perfect square value for our hypotenuse length. Like how it was for, what number was this? Number 1. Once I square rooted that 100, and we got the square root of 100 is 10, so C would equal 10. 100 is a perfect square, so that's why we got that answer. But when you get into reasoning, you will have a square root value that is not a perfect answer. So you may have to leave that number either in square root form, or you'll have to break it down into 2 different numbers, and more so just state that the length of the hypotenuse would sit between 2 numbers. So we're going to do that now. For number 5, we're going to label our A and B first. Rewriting our formula, write the formula every single time. I know that a squared, which is 9, plus b squared, which is 4, equals c squared. 9 squared is 81. 14 squared is 16. 81 plus 16 will give me 97 equals c squared. Now, if I want to just get c, which is that's what it's asking for, c would equal the square root of 97 because we just need the value of one of them. But once we get down into determining where that fits specifically, because obviously this is not a perfect square like how 100 square rooted is. So some questions may ask you to read it in this form here, square rooted, but sometimes, once again, we need to identify exactly where it will fit, and that's where we get into 6 through 8. Get into for 6 through 8. It says for problem 6 through 8, determine which two consecutive whole numbers. Underline that. That means you have two answers. Which two consecutive whole numbers the length of the hypotenuse is between. So all we're going to do is identify where that will sit at in between two perfect squares, the length of the hypotenuse. So just labeling, write your formula again. That's how you get it through your memory. You have 3 squared, just because that's our a, plus b squared, which is 3 squared again, equals c squared. That gives us 9 plus 9 equals c squared, which is also 18 equals c squared. Now they just want c, not c squared, so we have to square root both sides. The square root of 18 equals c, but it says which two consecutive numbers will this number sit in between? They're talking about the square root of 18. What two whole numbers would that sit in between if it was a perfect square value? So you essentially kind of just want to get close to where you're supposed to be. I know that 16 square rooted is a perfect square. I know that 25 square rooted is a perfect square. The reason being is because 4 times 4 is 16. 5 times 5 is 25. 18 will sit in between the numbers 16 and 25 on a number line in between perfect squares. Okay? So, if I was to do 4 squared, which is 16, okay, and somewhere between 5 squared, which is 25, that's where this 18 squared will sit. I'm sorry, 18 square rooted will sit. So C is between 4 and 5. That's it. You just need to identify which two values can make a perfect square and wherever those square rooted values sit. That's it. Nothing more, nothing less. Let's do one more. I'll do number 8, and I'll leave you to do number 7 on your own. For number 8, label first. You're just gonna make 12 our A, make 7 our B. Write your formula again. Get used to doing it. A squared plus B squared equals C squared. We're looking for C. I know 12 squared is 144. I know 7 squared is 49. If you add all of that together, 144 plus 49, that'll get you, let's see, drop the 3, carry the 1, drop the 9, drop the 1, equals C squared. That'll get you 139. But we have to square root both of them because we need to break this squared value down here. So we just need one C, an isolated C. So we know that C equals the square root of 193. But we need to figure out what two numbers would this non-perfect square value sit in between. Now, if you want to just have like a little cheat, you can just plug it into the calculator. Square root symbol, 193. That gives us 13.89. That is not our answer. That is not our answer. But what that will do is give you a good range, because that'll tell you either, look, it's going to fit in between 13 and it's going to fit in between 14. So in that case, you will round up or you will round down. Okay? So if I did 13 squared, which is 13 times 13, I'll get 169. If I did 14 squared, which is 14 times 14, I'll get 196. So that 13.89, if you round it up, that'll get you to 14. So that'll tell you where it'll come close to, and all you have to do is backtrack one number to know that it fits in between 13 and 14. Okay, so our range will be okay, between 13 and 14. Okay, it's only close to 14, but it didn't hit. That's where it would land at on the number line. This is just showing that this is our square root symbol. If you need to annotate this somewhere, just make sure you label it square root symbol. That's how it looks on every single calculator. If you ever need to shorthand, square root is right, SQRT. That means square root. Same thing on the calculator. This is our square root formula, and I'm going to shorthand this. All it is just x square rooted. We've been square rooting, but here it is again. This is just a demonstration of how to use square root for those who may still be confused. It gives us c squared equals 97, but to get one c value, because it's the c squared and we just need to know the value of one c and not two, you would square root it. Square root both values to get just the value of one c. Here, in number 9, it says to circle all the expressions that do not represent a whole number. The easiest way to do that is just to plug these values into a calculator. Calculator. Okay? If you plug these into a calculator and get a decimal, then it's not a whole number. So that is what you would circle. Now, if you do get a whole number, then don't worry about circling it. It's a perfect square. Like the square root of 4, for example, that is a perfect square. That equals 2. But it says to circle all the ones that do not represent a whole number. I know the square root of 1 is still going to be 1. That is a perfect square, so we don't need to worry about that. Same thing with 0. Same thing with 100, like a couple questions before. This is a perfect square. 10 times 10 is 100. So that'll get me 10. Now, if I took the square root of 10, let's say, just plug that in. Hit the square root symbol. Put in 10. That equals 3.16. So that is a number that we would circle that does not represent a whole number. Okay? I know off the top of my head that the square root of 81 is 9 because 9 times 9 is 81. That's a perfect square, so we don't need to worry about it. But if I do the square root of 8, I should come somewhere close to 3 point something because 3 times 3 is 9. But 2 times 2, 2 times 2 is 4. But I know that 8 will sit somewhere between 4 and 9. So this would definitely be a partial number or a decimal number. So that's the number you would circle. I'll leave you to do square root of 62, 27, and 36 on your own. We are going to move on a little bit. For problems 10 and 11, it says to use the square root notation to express the length of the hypotenuse. All that means is to leave once you get to your answer. So once you get here, matter of fact, let me rewrite this. So once you find your answer, and I'll just say x equals c squared. All that means is the square root, and then leave it written that way. So you'll put square root of whatever your number is equals c, and that is how you will write your answer. So you don't need to break down where it will sit. You don't need to break down the number from a perfect square. You're probably not going to have a perfect square number anyway. You should leave it in square root notation just like this for number 10 and 11. I'll leave you to do those on your own. Okay. Real quick, as we brief, what information do we need to find? Do we need to find the length of the hypotenuse? You need definitely the values for your A and your B. You need to know the formula for Pythagorean theorem is a squared plus b squared equals c squared. And then you'll plug in and punch in to find those values. Okay, to find the value of c squared, and then you need to square root to find the value of just c. All right, you use the square root notation to represent the hypotenuse when you have a value that is not a perfect square. Okay. And that's the only time that your x value will actually be a whole number, by the way. Going down to the exercise, going by. It says for problems 1 and 2, find the length of the hypotenuse if the answer is not a whole number of units. Use square root notation to express the length. So you do not need to determine yet where those answers sit. Just leave it as c equals the square root of whatever the number is. For number 3, it says the length of the hypotenuse in problem 2 is between which two consecutive whole numbers, and explain. So you'll set up your equations. You'll get c equals the square root of some number, and then it wants you to identify what two numbers will that answer sit in between if you were to break it down into whole numbers. So if you had two perfect square values, or if you had a perfect square value, what two would that particular square rooted value for two that you found sit in between? I hope that made sense. It sounded like a lot. But it's basically what we were just doing when we were reasoning here for this, for number 8. It's the same thing. You know how number 8, the square root of 193 would fit in between the perfect square values of 13 squared and 14 squared? Same thing for your executive. But do make sure you explain. A lot of y'all are losing points for not explaining. Just give me 1 or 2 sentences about what you did to solve, and that's it. When you're done with that, make sure you turn it in.